Hi, ladies and gentlemen. We are on our last page of notes, notes 5.4, which are on page 6, and they are on midpoints and diagonals in quadrilaterals. So let's just do a quick refresher of what it is that we learned in class when we did our stations. So if you guys remember in one of the stations what we did was you just got random quadrilaterals. And so what I'm going to do is I'm just going to draw a random quadrilateral. It's a four-sided figure. And I'm going to find the midpoints of each one of my quadrilaterals. And once I find my midpoints right here, I'm going to connect my midpoints. So right here, I'm just getting all the different midpoints right here, if you guys can see what I'm doing. And then right here, if I connect my midpoints, I end up getting a specific type of figure. And the figure that I end up getting is going to be here. This looks like it might be a rectangle, but it's not necessarily always a rectangle. It depends on what type of a shape we have inside of here. So if you look right here, now it's no longer a rectangle, but what we do notice is that we have a parallelogram. This side right here is parallel to this side. And let's verify it to make sure that they are really parallel by measuring their slopes. And if they have the same slope, then they are parallel to each other. And it's clear that they are parallel to each other. Let me just hide the grid. It's clear that these guys right here are parallel to each other because they have the same slope. And then let's see these ones right here. If I were to find the slope of this guy and this guy, I can see that those also are the same slopes as well. So since these are the same slopes, so we've got two sets of lines that have the same slopes, we've got a parallelogram inside of here. So, and it doesn't matter what I do to my quadrilateral, where I move the vertices of my quadrilateral, the slopes change, but the opposite sides always have the same slopes as each other. So I can conclude that if I were to, and let's write this out here, if I were to join the midpoints of any of the sides of any quadrilateral, it doesn't matter what kind of a quadrilateral I have, it would always produce a parallelogram. Now, not necessarily a rectangle or a square or a rhombus, but I know for a fact that it's going to be a parallelogram. Okay, so that's one important thing that we learned in class, and we'll draw a picture of that on our paper so we can kind of see what it is that's going on right here. So random quadrilateral looks like this right here. When I connect all of my midpoints right here, I end up getting a parallelogram. Okay? Okay, and then our last property for this unit has to do with parallelograms. So if you look right here, we have a parallelogram, and we know again that it's a parallelogram because if I were to measure the slopes right here, I can see that these slopes right here are the same. So let me just hide the grid. The slopes are the same for my opposite sides, and then let's just verify over here that these slopes are the same as well. So I'm going to measure my slopes as well, and I end up getting that these slopes are the same no matter where I place my values right here. My slopes change, but the opposite sides are always going to be the same as each other. Okay, so now that I've done that, I'm just going to hide this right here so I don't see it. I'm going to hide these values as well. So I'm going to create some diagonals. So I have a diagonal CB here, and then I'm also going to create diagonal AD right here. And I'm going to have an intersection point right here. And what I want to do is I want to see what is the length of the segment AE going to be. So I'm going to measure the distance right here, and it tells me that AE is 10.91 centimeters. So then if I measure ED right here, and I'm going to measure the length of it as well, and it tells me it's also 10.91 centimeters. And if I were to move my vertices around, the lengths change, yes, but they're still always going to be the same as each other. So AE is always going to equal ED. right here, okay? And then I'm going to also measure the length from CE, and that's 6.19. So I'm going to guess that the length from E to B is also going to be 6.19, and it is. And again, same thing when I move my vertices around, these values change, but the different pieces of my diagonal are always going to be equal to each other. So it's very clear that E is the midpoint of AD, and E is also the midpoint of CB. And basically what it means is that my two diagonals are going to bisect each other or cut each other in half. So let's go ahead and write that out. The diagonals of a parallelogram will always bisect each other. And remember, we wrote this down before. If we bisect something, it means that we cut it in half. So cut into two equal pieces. Okay, that's what it means to bisect. All right, so let's draw a picture of this. So if I have a parallelogram that looks like this right here, and I draw in my diagonals right here, so if I have this one diagonal and I have this other diagonal right here, I can say that this segment of my diagonal is congruent to that segment of my diagonal, and this piece of my diagonal right here to the midpoint is congruent to the other half of my diagonal over here. Okay, now we're going to apply what we discovered in class and just now as well a second time around to some problems. All right, so in number 1, it says in the diagram below, M, N, P, and Q are midpoints. So if M is a midpoint, we can say that those two segments are congruent. If N is a midpoint, we can say that these two segments are congruent. If P is a midpoint, I can say BP is congruent to PC. And if Q is a midpoint, I can say that CQ is congruent to QD. Okay? And since they're all midpoints, we can also conclude that MNPQ is a parallelogram. And if MNPQ is a parallelogram, then we know that MN is parallel to QP, and we also know that MQ is going to be parallel to NP. So we can say that MN is parallel to PQ. That's one of our answers. And MQ is parallel to NP. And we are good to go for question number 1. Okay, so question number 2, it says that we have a parallelogram called ABCD. So I'm going to draw a picture of ABCD right here. And we have some diagonals, and we know that the diagonals are called AC and BD, and we know that our diagonals are going to intersect at E. Okay, it tells us. And then it also tells us that AE equals 7x minus 1. So I can go ahead and label in that information right here, that AE right here is 7x minus 1. And it also tells me that EC is 5x plus 5. And remember, we figured out up here that the diagonals of a parallelogram will always bisect each other. So that means that I can conclude that this segment AE is going to be congruent to EC. So I can say, in order to find out what x is, I can say that 7x minus 1 is equal to 5x plus 5, okay? Because again, since they bisect each other, the first piece, the first half of my diagonal will be congruent to the second half of my diagonal. Solve for x by subtracting 5x from both sides. I get 2x minus 1 equals 5. Add 1 to both sides and I get 2x equals 6. Divide by 2 and I get x equals 3. So right here I can say x equals 3. And then it asked me to find AC. Well, AC is from one diagonal all the way to the other. So I can say that AC is going to equal 7x minus 1 plus 5x plus 5. Okay, so I can say that AC is going to be 7 times 3 minus 1 plus 5 times 3, and then we've got plus 5. Okay, so then I'm going to evaluate this answer, and then I will be good to go for this right here. So 7 times 3 is 21, so I get 21 minus 1 plus, this turns into 15 plus 5. So I end up getting 21 minus 1 is 20, 15 plus 5 is 20, so I get 40. Therefore, I can say that AC is going to equal 40. Okay, and we'll put a box around this right here to identify the x is 3. And then lastly, it tells us that dB is equal to 10x plus 10. And if dB is equal to 10x plus 10, I can say that it's going to be 10 times 3 because, again, I know that x is 3. I already solved for x right here. So I can say 10 times 3 plus 10, which is what dB is, or I can say dB equals 30 plus 10. So therefore, dB is going to equal 40. Okay, so now that I've done that right here, it actually ends up being that my two diagonals are congruent to each other, which will result in a rectangle, but that's a property that you don't have to worry about right now. Okay, all right, I hope you guys have a great day, and I will see you next time you have class. Bye.